Today's lesson is going to be about absolute value inequalities. Your essential question today is, what does absolute value tell me? So what does absolute value mean? As you can remember, that the absolute value of x equals 3 means that x is 3 away from 0. It describes the distance that a number is from 0. So x can be -3 or 3. But think about it like this. What about the absolute value of x being less than 3? What does this look like? Think about it. Doesn't this basically tell you that the distance between 0 and x is less than 3? Well, if you think about absolute value of x and 3, couldn't you think about x at -3 and x at +3? And you want the distance between whatever x is and 0 to be less than that. So that would be anything in between, because any number in between these two values is going to be, their distance between 0 and that number is going to be less than 3. Whereas, if you look at this one, the absolute value of x is greater than 3, think about what that looks like. Well, we still have 3. So what are our absolute values of 3? Well, -3 and 3. -3 and 3. And think again, what is the distance between x and 0? The distance between x and 0 is greater than 3. So give me a number that has a distance between itself and 0 that's greater than 3. 4. Wouldn't -4 be the same too? It would. The general idea behind this is that we want to think about, we have a value of x, and what we want to measure is we want to measure its distance. Remember that distance is always, always, always positive. So, say for example, we're given this, where it says solve, and I have the absolute value of x is greater than or equal to 6. Well, thinking about absolute value, what are my values for 6? What numbers have a distance of 6 from 0? Well, we know 6 is, right? But also -6. Isn't -6 also 6 points away from 0? It is. Now, I want the distance to be greater than or equal to. If we remember our graphing, we want a full dot, we want our distance to be greater than that. Well, if this is where 0 is, give me a number that has a distance greater than 6 from 0. 7. 7 is over to the right. Isn't -7 the same? It is, which is to the left. So that's what your graph would look like. If we try another one, this one here is saying solve and graph, and I have the absolute value of x is less than or equal to 0.5. That tells me that the distance between whatever I have and 0 has to be less than 0.5. So I make my graph. There's 0. There's 0.5. And again, the opposite of it, -0.5. Bear with me, 7th graders. I'm writing with my laptop. Am I including the values? Yep. So close circle. And I want the value to be less than or equal to it. What number would have a distance less than 0.5? 0.2, wouldn't it? Isn't that going in to 0? And how about here? Wouldn't -0.2 also be the same? It would. So that would go in. So I want you to take a look at our two graphs. And I want you to think about, how does this connect to what we were doing yesterday with compound inequalities? Take a look at where the symbol is facing compared to your absolute value. Take a look at your two graphs. Do you notice something? Does one look like an and statement and the other one look like an or statement? It does. So, an absolute value that is less than produces an and compound inequality, where your graph goes together, whereas an absolute value that is greater than produces an or compound inequality. So let's think about this. What if I'm asked to solve an equation and I don't just have x? So how do I solve absolute value inequalities? Well, your first job is to get rid of everything outside of the absolute value sign by doing the opposite. Now you do that, all of you tend to do that by doing the inverse operations. So if I had anything outside of those absolute value signs, maybe I had like a +2 or a ×4, I would first get rid of it. Because the thing is, I can't do anything with the stuff inside until my next piece. Now, you're going to write as a compound inequality. What you do is you take your absolute value bars away and put one with the positive and switch the sign with the negative one. Think again why we switch the sign with the negative. If we don't switch it, the value doesn't come out the correct way. That was true when we did multiplying and dividing with negatives and solving. And we proved it by talking about values that will go in those inequalities. So, just like that. Notice that my sign in this example is less than or equal to. It stayed that way with my positive value, and I flipped it with the opposite value. Now, you solve, and then you graph. So let's do an example together. Again, forgive me, I'm doing this on my laptop. So, what does my first piece tell me? Get rid of anything outside of my absolute value signs. I see nothing outside of my absolute value signs. Okay? So this is telling me that the distance between whatever I have is less than or equal to 7. This could be very abstract for you right now. Where this idea comes into play is actually when you start doing statistics. You start talking about standard deviation and how far away do my values move away from the average or away from the middle number. And so this basically is just reinforcing the idea we're talking about the distance. And the distance has to be a certain value. In this case, it's less than or equal to 7. So my second step is rewrite it. So I take what's on the inside, x minus 3, and I'm going to do it the same, x minus 3. Notice how even though I'm going to take the opposite on one of these, that's a really awful 3, isn't it? What I'm going to do is I don't worry about anything on the inside. It's just this part that I worry about. Now, my sign stays the same for the positive value, and it switches with my negative value. What's the opposite of 7? It's negative 7. And what's the opposite of being less than or equal to? It's going to be greater than or equal to. And then you solve. Well, inverse operations, add 3, add 3. To make that a true statement, x has to be less than or equal to 10. For this one, add 3, add 3, and x is greater than or equal to -4. Now, if I were to graph this, I'm going to put 0 on there because that helps me. What are my two numbers? -4 and 10. Am I keeping the value or not? I am, because I see that equal to piece. So I want a closed circle. Now, do I want the distance to be less than or greater than? Well, I want it to be less than. And so my values go into the inside. So what this is saying is I want the distance between x and whatever else I have, I want to be less than 7. If I take x and I take 3 away from it, the distance between that and 0 should be less than 7. You can take any number within that here, and it fits. Now try a few more examples together, and I will also put the solutions up. So at this point in time, pause the video and have the students try these two problems on their own, and then go over my solutions as a class. I had nothing on the outside, and so what I'm doing is I'm just making my two inequalities and I'm going to solve them. That should be a -11. Those are my two. Now when it comes to my graph, there's 0, 6, -5. I have an open dot, open, and my distance is greater. So my graph goes away. Again, I take a look. I have nothing on the outside, my absolute value bars. So I'm not going to worry about that. And then I'm going to write my two inequalities. I solve for x for both of them. All right, take a look. I'm all solved. I'm going to make my number line. I have 0, -2, and 7. I have a closed dot this time. And I want my distance to be greater than, so it will go away. Okay, so take a look at my solutions, ask questions, collaborate with each other, see if you understand what's going on. Now, I want you to go and write your summaries. And remember, our essential question for today is, what does absolute value mean? So take some time, write your summary, and then you'll work on your individual practice.